Hello and welcome to part 3 of event-driven programming. So in this part we are going to implement the software design for the ticket machine, and I'll explain as we go through how we are meeting the requirements of the course by doing the various parts of it. You'll remember from the introduction that event-driven programming is all about a continuous loop that responds to interventions from users. The interventions might in some cases come from other systems or from sensors, but in our case they come from users. So the general outline of our event-driven program is any actions we have to carry out on startup, and then while the shutdown flag or variable is false, it will loop and just continue looping and looping, processing any instructions that come in. And then when something causes shutdown to become true, the while loop will end and the shutdown process will be carried out. So in the case of the ticket machine, you have been given the analysis for all of the tasks that the system needs to perform, and that's on page 7 and 8 of your workbook. We can see that there are two events that we need to write handlers for. One is the user requesting tickets, and that includes all the stages of the user selecting their options, paying for their tickets, the validation of their payment card, and the delivery of tickets. And then separately we have the management function to handle, and that's validating the manager PIN and confirming whether shutdown should take place. So there is pseudocode provided for one possible solution, because there's many different ways to design these programs, but there's a pseudocode provided page 8 to page 9. It looks like this, and I'll just talk you through the bits that are given in detail here. So we're going to have a process that starts up, and you might remember that that's going to involve reading ticket prices in. A crucial step, initialize shutdown to false. So our loop will never begin unless shutdown is set to false. Then we can say while not shutdown, and that's us into our loop. We're going to ask the user for their first input, which is from the design that you've seen exampled here. The first thing we ask the user for is how many stages of travel they're buying tickets for. And you might also remember that if you're trying to get into the manager function at that point, then you type M. So if the response to that prompt is M, then you call the event handler that deals with the manager function. Otherwise, you handle the user's response. And that's it. You have just handled the two possible things that can be input at the first screen. Now, as a result of calling this function the manager function, it's possible that the shutdown flag, and flag's just another term for a Boolean variable, the shutdown flag may have been set to true. So when we come out of that if there, we need to say if shutdown is not true, then we need to display the welcome screen again. Then we reach the end of the while loop, and at this point it tests for shutdown being true, and if shutdown is true, we come down here to shut system down. Otherwise, it rolls on round again, waiting for the next user to come along, prompting with the number of stages. Now we've gone into, so that pseudocode that we've just looked at from startup down to shut system down, that's your main program. And just going into refinement on startup here, the details of the startup function are that you're going to read the ticket price information from the file ticketprices.csv. You're also going to note the startup date and time, because that's something you need to have available at the time that you come to shut down. It records how long it's been running. And lastly, you display the welcome screen. So the welcome screen gets displayed by the startup routine, and it gets re-displayed after the event handlers have been called here if we're not in a shutdown state. So you would need further refinements, more pseudocode for the manager function and for the ticket sale handler. So you're going to develop your solution, and this is so what I'm going to do here is I'm going to step through all the different parts of Learning Outcome 1 so that we know we've met all the requirements of it. And by the time we've done that, you'll be well on your way to having your solution developed. So it tells us that we need to select, declare and initialize variables and data structure types and sizes to implement design requirements. And what we really need to interpret that as is creating classes. We need a class for our ticket price information. I will do this one first. So the ticket price information, you might remember, is in ticketprice.csv in 3 lines of information. So you will need an array to contain 3 instances of your class. Each one will contain the number of stages, so that's 3, 6 and 9, the full fare and the concession fare for that number of stages. So here's a possible structure for the class. I've called it ticket price, and you give it open and close brackets, and then it's got to have, you might remember, an init function, an initialization function with double underscore init double underscore. It then takes arguments where self has to be the first argument, and the other arguments are the ones that you will provide it at the time that you declare the instance of the class. This is me declaring an array that will hold 3 instances of the ticket price class. Then, for each line that I read from the ticket prices file, I will append another instance of the ticket price class to this array, and I'll show you this. This should all be familiar. The reading from the file, the splitting the arrays up should be familiar, and using classes, that's the bit that I directed you to in the workbook that you might not have done before. So here we are, reading the data into the array of class ticket price. I've declared T lines as an array. These are temporary variables that we'll just use while we're processing the contents of the file, so they are local to the startup function. T lines and line parts. So this is my file handle, T file equals open ticketprices.csv. This is assuming it's living in the current folder where the program is. We're opening it for read only, so that's R in double quotes. And then we've got to add this encoding, which interprets the characters correctly, saves you getting funny characters at the start of the file, and that's all to do with the Windows platform, what platform Python is running on. So my T-lines array, I'm doing a single read function here. We take the file handle, we use a read command, but we add the dot split lines so that it's going to put the 3 lines that it reads in the file into separate entries in my T-lines array. And you've done all that before in the software development course. Then I'm going to close the file. So now I need to process what I've got in T-lines. Process each line of data into its components, it says. I'll do this in a for loop for line in T-lines. So line is a local variable that's just going to take an individual element of my T-lines array, and you might remember that's a comma separated line that says 3, full fare price, concession price. Line parts equals line dot split on the comma. So line parts is another array and it takes the first line of T lines and splits it into different components, sorry, here we are, into different components at the point where a comma occurs. So line parts now has three things in it. It has, for the first line, it has 3, which is the number of stages of travel. It has the full fare price and it has the concession price. So what we do now is we build that into our ticket prices array, ticket prices.append. This is us making a new instance of class ticket price. The init function needs us to provide stages, full fare and concession as the 3 arguments. So the first of those is line parts of 0 converted to an integer. The second is line parts 1 converted to a float, because that's a price, and line parts 2 converted to a float. Now, if you can relate that to exercises you've done before, I think you won't find that too confusing. The opening the file, reading it all at one fell swoop, but adding the split lines argument so that you know you've read it into an array where each of the 3 lines of the file is on a separate entry in the array. Then this part is about breaking each of those lines up at the point where a comma occurs, and then putting that into our ticket prices. So the other part that we have to consider is the ticket sales class. This is a class for holding the details that get written out on shutdown. And those are the startup date and time, the total full fare sales and the total concession sales, and then finally the shutdown date and time. Ideally, we would create this class when we start up, and we'll take a note at that point of the startup date and time, and the rest of it will get populated when we go to shutdown. So on shutdown of the system, you'll update it with the latest sales totals and record the shutdown date and time. So here's a suggestion for the class that you might create. The ticket sales with its open brackets and its init_init function, initialization function. And you need to pass in all of the 4 arguments that it needs to store: start date time, full fare total, concession total, end date time. Now, how do you get the current date and time? At the top of your program, the very top, you need to include this statement: from date time, import date time. It's strange syntax, but it's about including a library of functions that handle date time type functions. And it will allow you to get the time like this. You could assign into a variable like start dt, and the call that you're making is datetime.now. So that's getting the current time from the system clock in the computer. So you can then initialize an instance of your class as follows. And I'm using here the stirftime method to format the date string, because we've been told the format that we need to put the date and time into. So tsales becomes an instance of ticket sales, which is our class up there. And here we are passing in the parameters. And at the moment, we've only got the startup time. We're just putting in 0 for our sales totals and a blank for the shutdown time. But here's how we're formatting the start date time. So you've assigned now the system clock into start date time. And by using the .stirftime method, you can use this format: day-month-year space hour : minute. So moving on to that section was about the class structures that you need to develop and the handling of files, getting the information in and out of the files. The next section is about implementing the screens, the user interface. The actual wording of this part of the learning outcomes really relates to a graphical user interface, which we're not doing. But what you should do here is make a nice modular solution for designing your screens. And by that I mean reusable code. You might remember that modular programming was about smart use of functions. Whenever you've got the same thing happening in one place and happening again in another place, you'll write a little function that you can then call multiple times over. And an example, a perfect example for that would be when you designed your screens, did you put a banner at the top, like My City Metro, for example, as you saw in the example earlier? If that appears at the top of each screen, you can implement a display banner function, and that would be reused. It wouldn't matter which screen you were showing, the first thing you would call would be display banner. So here's how that could go. Def display banner, the comment tells us what it's doing. Remember to comment all of your functions to say what they're doing. Print banner title, it prints 70 underscores. It then prints My City Metro, spaced so that it's going to appear in the middle of the screen, and prints another 70 underscores. And that is the banner. So really, in terms of good implementation of your user interface, we're just looking for reusable code that will hopefully help you get a nice consistent layout to your screens. Now we need to consider the events that we're prompting for on our screens, and we need to implement the event handlers that will deal with those. So we need to consider the overall shape of the program with regard to these events and when each screen will be displayed. So when will we first display the welcome screen? You could do it in your startup routine, or you could do it in your main program just before you enter the main loop. Once we go into our while loop, we need to be waiting for a response from the user. So we need to display our first screen before we get into the while loop. When you get your first user input, you will enter your ticket sale event handler, and you'll display the other ticket sale prompts to the user. However, we've also got to cater for this part. When the user enters M for manager, you'll call the management function event handler and display the manager screen. The other thing we need to consider here is the scope of variables, and that would be, for example, our array of ticket prices. It needs to be available to all of the main program. So think about where you're going to declare that array. So we're implementing our event handling using control structures, and that is basically your while loop. It's time to write your event handlers and call them from a main loop. I would recommend that, and this is generally really good practice in programming, that in order to get the overall shape of your main program, you would start by creating stubs for your functions, and stubs are just empty functions that just indicate that you've called them. So they'll just put a message on the screen to say that you've called them. So the manager function needs to be, the manager function needs us to pass in the shutdown flag. So we call it like this with the shutdown argument, but at the moment we're not going to do anything in here. We're just going to say stub for manager function, print manager function on the screen. And the same for ticket sale. It needs to know how many stages, it needs all the ticket price information, it needs the ticket sales class that we set up because it's going to tot up the full fares and concessions. I can't remember how I've laid out all that bit. We'll explain that bit shortly. But at the moment, this is just a stub. So regardless of all these arguments that it needs, it's just going to say ticket sale function. So that will let you concentrate on setting up the main loop, seeing it respond to input by just printing these messages on the screen. And once you've got that structure in place, you can then think about startup, shutdown, and then the event handlers. So let's look at the shape of the overall loop. And this relates to pages 8 and 9 in the workbook. It relates back to the pseudocode that is on page 8 and 9 in the workbook. So you should see the shape of the pseudocode here being implemented. So we've got a comment to indicate when we're into the main program. That's an important one because I've certainly seen a few examples in the class of people not being clear about when they were doing their subroutines above. That's the defs up above, and then you should always have a comment to indicate when you're coming into the main program. So our first little bit is initialization and startup. Here is our array that will hold ticket price information, and here is the call to our startup function. Passing that array in, tprices array gets passed in. It also gets returned out with price information populated. We've got an array for the sales of the full fares and an array for the sales of the concessions for each of the number of stages of travel. So, crucial step in the main loop, we need to initialize the control loop variable. We want shutdown to be false, otherwise the program will never start. It will just jump straight down to the end of the while and perform shutdown. So shutdown needs to be false, and here we are prompting the user for how many stages of travel. We know that the user might have taken this step of typing M to get the hidden manager function, in which case we need to call our manager handler. Otherwise, we call our ticket sale handler. Lastly, we test whether shutdown has now been set to true. If we are not shutting down, we need to display the welcome screen again and come round our main loop. Now, if you write that with stubs in place, you will have all of the main loop structure sorted, and we can go and look at the detail of the startup and shutdown. I think that's the next part. Yes. So we're going to write the startup routine, which reads the ticket prices file. And we need to have declared an array to hold the 3 ticket price entries. Where should this be done? Because it needs to be available to the main program, but it also needs to be available to the event handler. You could do it, one of the possible solutions is to do it at the start of your main program. So we saw this on the previous slide. Before we get into our main loop, we've done some initialization. Now let's look into the startup routine. Now you can open the ticket prices file and remember to use this encoding equals UTF-8 sig. Read the contents into an array of separated lines, and I'm just reminding you how that went back in the software development course on page 119 of the blue workbook if you need a reference. You need to have a ticket sales class defined, and that's going to let you record the startup date and time. So we need both of our classes defined, our ticket prices and our ticket sales. So here's the startup routine. It opens the ticket prices file using the appropriate encoding, read only. It reads everything in, it closes the file, it loops through the array that's just been read in, splitting it out into individual parts, and then initializes a new instance of ticket price like this and appends that to our array. So you will see that happen for 3 stages of travel, 6 stages of travel, and 9 stages of travel. Now we need to find out the startup date, the date and time just now as we're starting up, and we need to declare an instance of our ticket sales. And we looked at this earlier where we're using stir_f time to format the output, and then the rest of the variables are still empty. Now we display the welcome screen. You might still have that as a stub, or you might have lifted your code from your prototype to bring over all the print statements that give you the nice layout for your welcome screen. And then you return your ticket prices and your ticket sales to the calling program so that all of that information you've read in is available to the main program. Now let's look at shutdown. So I've called the function perform shutdown, and it needs the ticket sales passed in, and we need to note the date and time just as we did earlier. So this is us taking the shutdown time. So we can now assign that ticket sales.end time becomes now, and I'm using the formatting method again, stir_f time, so that it comes in the same format, day hyphen month hyphen year space hour colon minute. Open up the file for writing, so that's W+. The plus means you're creating the file. It makes a new file each time. And you write the start time, the total sales for full fares, and the total sales for concessions, and the end date time. And it separates these with commas. This bit here, the backslash, that is a line continuation. So I've split that line because it was a very long line of code. And that's what the backslash does. You just interrupt the line and move on to, and basically press enter so that it goes down onto the next line. But you need to introduce the backslash character to continue it. And then close the file. So we've met quite a number of the parts of the learning outcome 1. You need to complete the development of the rest of your ticket machine app using Python. Remember to, in designing your screens, to make a nice use of white space so that they're clear. Imagine you're a user approaching it in a busy metro station. It needs to be shouting out nice and obviously to you. So you're going to use the print function for the elements on the screen that are display only, and you're going to use the input function for each user prompt. The other useful functions that you might need are mentioned in section 1.8 of the workbook. And the next tutorial covers some refinements to your program. So if you can get that basically up and working, then we'll look at some refinements that are required as part of outcome 2 and testing, which is outcome 3.